there's a strict plug and chug, as you guys are in the back of your homework spirals, for those of you absent today. In the back of their homework spirals, doing a section 9.2 last practice. There is a strict plug and chug. It's like, okay, I'm looking at my notes. Well, I guess I'm doing this, and I guess I'm doing this, and I guess I'm doing this, right? That's the strict plug and chug. To find S sub n, you do n over 2, a1 plus an. Is that okay? So n is 10, n is 10, n is 10. I mean, I already plugged in 10 and 10 and 10, but what else can you plug in? 4 plus, what was a little bit sad? Not 63, not 9 times 7, but why is Joe saying, everyone else, why is Joe saying, why is Joe saying, no, why is Joe saying 9 times 7 is 63?
Because n minus 1 multiplied by d.
What's Jason? What formula? The other one. Okay. The other one. That's cool. I'll take it. I'll take it because can't you get A10 from A1 plus n minus 1? Oh, wait. N was 10, right? 10 minus 1 times d. So then we know that A1 is 4. We know that's 9. We know 7. Okay, so the 9 times 7, using the other formula, we end up with 60. What is the 10th term? 67. Isn't 63 plus 4? And so 71 times 5? That's the formula. That's the strict plug-in. And to do the strict plug-in, like, I'm stuck. No, I'm not. I'm going to go down. I have another strict plug-in I can use. Put them together. Woo, got it. What was the other way? There was another way? Yeah, you could have kept going. You could have been 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Huh, that was lucky spacing. Anyway, wait a minute. No, that wouldn't have been it. What would you still have had to do? I'm not done yet, right? What would I have still have had to do? Hold on, Lauren. Give me 1 sec. What have I done right now? No, what have I done? Past tense. What have I done? Not what am I going to do? What have I done? No, what have I done? What did I just do on the board? I made that. It's not a sequence. Careful, there are pluses. I made the series, right? And how did I make the series? How did I do it 1 by 1? 1 by 1, I mean, you could do 2 by 2, but those are the animals in the ark. What did I do?
Add 7 to the previous term.
What previous term?
4.
So what did I technically do? I started at 4. And then what did I do? See, the sequence of events are important. Sequences, series. Okay, so I started at 4, and then I added 7. Then what did I do? I kept adding 7, and as I added 7, I was multitasking. I was keeping track of my terms. You guys hear me say 1st, 2nd, 3rd, 4th, 5th? As I was adding? I got all the way to the 10th. Bloop, bloop. But then I was like, and I'm still not done, because I'm supposed to be getting that guy. So what would I technically have to do that guy? Oh, stink. That's 15, and then that's going to be 30, and no, that's going to be 43, and then that sounds awful. This is what little Gauss, little elementary genius math kid that no one knew was a genius yet, did when he was sitting in class one day. They were being rowdy. poor little teacher was just like, I am sick and tired of you all. She didn't say that, I don't think. But what she did do is she said something to the effect of, all of you sit down and on your slates, because they had the chalkboard slates, add all the numbers 1 to 100. She's like, oh, I'm going to get at least 10 minutes apiece. All the little heads were like, oh. I think they were going to lunch or recess or something like that. But within just a matter of moments, little Gauss came up and was like, here you go, 5,050. Teacher, of course, was like this little punk kid. He just wrote down a number and didn't even do it, but poor teacher hadn't even done it yet, so she had to figure out what it was in order to be able to check whether or not he was going to know, that's right. She was like, oh, I'm going to prove you wrong, started adding. He was right. But he didn't add all the numbers 1 to 100. He saw a pattern. And the pattern was, instead of doing 1 plus 2 plus 3 plus 4 in sequence in order, he noticed, which now applies to any arithmetic sequence, that all you have to do is say, hey, 1 plus 100 is 101. And 2 plus 99 is 101. And 3 plus 98 is 101. And guess how many 101s there are going to be? Well, it takes 2 numbers to make a 101. So how many pairs are in 100 numbers? What's 50 times 101? Granted, he was a smart one, so he did that one pretty quick too. But 5,050, and he was done. Her plan kind of backfired. Hopefully he wasn't the ringleader. But anyway, 5,050 and he was done. So what can we do on this one down here? Same thing, but it's different. It's starting at 4 and it's counting by 7s, but it's still arithmetic. No, it's okay. Joe's right. It's arithmetic, but thank you, Jason. Joe's the one that came in and was like, wasn't there the story on, we were talking about it. It's like, yeah, I ran out of time. What's 4 and 67? 71. What's 11 and 60? 71. What's 18 and 53? Hey, venture a guess? 71. How many 71s are there going to be? You guys in the back, I heard you guys in the front like, did you multiply by 5? Why? Because there are pairs. The first plus the last. In any arithmetic, there are going to be half as many numbers. The number of pairs will be half as many as the terms that you have. Wait. What if you have an odd? If you have an odd, there's going to be a guy in the middle. Yeah, he's going to be in the middle, so he's going to be a half of what is going to work out just fine. So then the other way of doing it, besides like actually just, I don't know, plug and chug, and we need them, plug and chug, just take the first, take the last, 71. 71 times 5 is going to be 355. Now what's the bummer of this? Like, it's a cool trick, but the bummer is, yeah, the formula only makes like quick sense if you know the first and you know the, if you don't know the first and the last, are you going to have to kind of do the work or jumpity jump to get there? Yeah. Now what if I said the S sub 20? You're going to do this whole thing and then be like, oh, look, it's a trick. No. You're going to be like, let's go find the 20th and let's just forget the whole like writing it all out. Does that make sense, guys? This is the one formula, well, the 2 formulas that should make a lot of sense mathematically if you can wrap your head around where they came from. A sub n, remember, that we saw from yesterday? And you guys just did it right here. A sub n, if you're just jumping between my first finger and my 5th finger, how many spaces do I have? 4, right? So how many jumps? 4. So to get from the first term to the 10th term, how many jumps of my common difference? 9. That's very logical. And then once we get our last term, well, sweet. Those added together are going to be the same as the sum of all of them for 10 over 2 or n over 2 pairs. Got it. I did have a word problem, something. Let's just go to the homework and see where you guys got stuck. Sound good? Section 6.2. 9.2. Uh-oh, I had an, it's not even dyslexic. I don't know what that would be. Upside down moment. Anyway. Section 9.2. Starting on number 14. Let me crack the door a little bit. At first it was nice. Now it's stuffy. What's the nursery snacks from yesterday? They had goldfish and granola bars. Someone had a bagel. And they were coloring, what were they coloring? The woman washing Jesus' feet with her hair. Anyway, Mr. Carmichael's church. Section 9.2. I think Mrs. Regan was in nursery yesterday. Section 9.2, number 14. I think you were just finding the first 5 terms. Yeah? Common difference was -3 because it was going down 3. Number 40, first 5 terms, 200, 190, 180, 170, 160. Easy peasy. Number 48, from what we did at the beginning of class, how would you read this? What does this mean? It's the sum of the 7 terms. And you should probably put in first 7 terms. There you go. There you go. Is half as many pairs of the first and the last. Does that make sense? The 7th partial sum, half as many pairs? Or pairs of the first and the last? I guess pairs by definition would be taking every 2, right? Yeah, 1 plus 19 equals 70. Number 54, ooh, they had you doing all sorts of stuff. But they did tell you it was arithmetic, and I can see that, can't you guys? Plus 4, plus 4, plus 4. So you have the first term, you have the common difference. In order to get the 50th partial sum, you guys going to jumpity jump, jump, jump all the way there? No. We're going to use the formula and say, let's just start at the first and do 49 jumps to 4, please. Ah, typo. What's that supposed to be? It is supposed to be a positive, but hold on. Look at the context. What is supposed to be there? What happened? It was an equals. Yeah, somehow the top line. I think it was in their printing, because we've seen that a few times. That was supposed to be equals 190. Put in the 190 first, last, half as many pairs. Got it. Should just say 25 pairs. DA. Was the matching kind of weird for you guys, or did it go okay? It was okay? Because you guys, like after working in your calculator, hopefully you realized, okay, this is going to be your a sub 1, right? Because it's on the 1. That's your a sub 1. This is your a sub 1. So an a sub 1 of like, what would that be? 20. Are these going by 3s? That's awkward. Okay. Like 22-ish, 23-ish, somewhere in there. Versus an a sub n of like 3-ish, versus an a sub n of like -2-ish, versus an a sub n of like 7-ish. You didn't even need to know anything else. Just plug in 1 for everybody and figure out who's who. But then some of them are adding to make it higher. Some of them are subtracting to make it lower. And most of you probably just thought of mx plus b and were like, yeah, it's like a line anyway. Oh, and that was it? What? All right. Where did we get stuck? Anywhere? Questions going once. Yeah, Lauren. Well, if it was a calculator portion of the test and I didn't say anything about the nth partial sum formula, like for instance on this test, if I let you use the calculator for the whole thing, just because some of the numbers get big, like even in the formulas they get big, right? So if I was to try to be like, okay, well I don't want you to get something wrong because your multiplication is off, even though we'd be able to do multiplication, but anyway. I would probably do something on the test where I said something like, find the 10th partial sum, and then I have a little s sub 10 equals blank. So you could throw the sum, the sigma, into your calculator, but then you won't get full points unless you show me the formula. That could be a way of me working the system. Does that make sense? Yeah, when it's actually a sigma. Well, let's look at the directions. Sorry, that's what I was leading up to. So looking at the directions as to what they were asking you to practice. Awesome. These ones, totally fine. They literally say, like, throw it in your grapher. But were there any ones where they didn't ask you to put it in a grapher? Oh, yeah. Thanks. I wasn't looking high enough. You see the difference between the two sections? Like, the one down below literally said, like, hey, can you use your calculator? And hopefully you were like, yeah. But these ones, how on earth did they expect you to do this without a calculator? Now, I don't know which ones. Lauren, can you give me one that you guys actually had, like 163? I mean, basically, if we just think of the idea of what we just talked about as far as the wording, right, as to what this actually meant, let's see if we can tear or break this down. Some of you already did it in homework. That's awesome. Try not to just give the answer. Try to instead help us think through the steps, like how we can, the steps, not just the answer, the steps as to how we can break this down and say, it's really just an S sub n. Do you guys see that it's really just an S sub n? Because at the end of the day, you're going to be adding A1 plus A2 plus, what's the last one? Because you're plugging in 1, plugging in 2. Remember, 1 is the first position, but then we also get a term out. So we're going all the way up to 500. So really, this is an S sub 500. It's just written in a really nice way. And it's written in a way where it's like, oh, you want A sub 1? Sure, here you go. How do you get A sub 1? Plug in 1, right? Okay, so A sub 1, well, I mean, I can say A sub 1 is just 9, right? Well, what's my common difference? Well, I don't know. Plug in 2. 10. Plug in 3. 11. Huh. Kind of looks like my common difference is just plus 1 plus 1 plus 1 every time. Oh, so my A sub 1 is 9. My common difference is 1. And what else do we need for this formula? Well, isn't it going to be half as many terms times A sub 1, which is 9, plus all I need is the 500th, right? Well, the 500th, how many ones are we going to be adding between the first and the 500th? 499. So we can say, oh, sweet. So it's 9 plus 499 times 1, which is going to be 5. Got it. So that would be your way of filling in the blank with the S sub n formula. Is that cool? And then technically, once again, should you be able to do 250 plus 517? You should be able to. Does that mean you want to? Well, maybe not so much. Although it wouldn't be too bad, guys. Couldn't we move that 0 to be over there, and then we can multiply this by 25 and just think that you have 5,170 quarters? Because 4 25s makes 100. So you could be kind of snazzy, and you could be like, I don't want to multiply that. That looks gross. I'd rather divide it by 4 and figure out how many 4s go in and then just multiply that by 100. If you want to be super cool. So we'd have 1, we'd have 11, so we'd have 2, and then we'd have 37, which would be 9, and then you have, oh, it's going to be something fractional? That's sad, because it'd be 10. But either way, multiply that by 100. Just move it 2 decimal places. Dun, 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 dun. Have fun with your 2-column multiplication. All right. Was there anything else in homework? Boop, boop. 75? Yeah. Okay, 75 might be funny, Selma, because of how it looked. But the nice thing is you could, in your calculator, because this was a calculator utility, you didn't have to do this one by hand, so that's why it looks nastier. But remember, you don't have to do it with the I. The I is just a variable. Could be K, could be X. So if I were you putting it in the calculator, I would just do N. Totally fine. And then you could do it 2 different ways. If you're in the calculator, you technically could do like 2 divided by 5 times N. Or you could do instead like 2n over 5 if you were doing your fraction. Or you could literally just do 2 over 5 times n. Either way, just use your n. It's okay. And then you know how to do the math and then, yeah. So not imaginary numbers, nothing crazy like that. Anything else, guys? Going, section 9.3, gone. One of my favorite sections. For a few different reasons that you guys won't really understand until we get to chapter 12. Whew! Chapter 12. Don't worry, we're skipping chapter 11. 3-dimensional vectors. Aww. I know. It's a sad day when you hear we're skipping that one. Section 9.3, geometric. You saw them last year. Arithmetic and geometric. Arithmetic, the pattern. Plus D, plus D, plus D, plus D, plus D. Geometric, the pattern. Which one did you learn first, arithmetic or geometry? It's okay, it's okay. But now that you know what I mean. Which one did you learn earlier, arithmetic or geometry? Oh, I just mean like the actual branch of math. I don't even mean sequences and series. I just mean the branch of math. Yeah, totally arithmetic and like little itty bitty school, right? Yeah, adding and subtracting. So that's why I think arithmetic is the easier operation of addition and geometric is the harder operation of multiplication. I don't know, silly way of remembering it. Arithmetic, earlier, addition, or subtraction. We could be adding a negative, right? Geometric, learned it later, or at least we tried to learn it, hopefully. SAT will thank you. Colleges will thank you. Geometry you learn later. Multiplication. Yeah, it'd be helpful for the ACT too. Although ACT is a little less typical. Ratio. So difference, we knew that word. Difference meant subtract. Ratio means division. Yeah, if you're making a ratio, you're making a fraction. Making a fraction, fraction bar is division. You guys see the division. So just like with arithmetic, we could subtract to find what had been added. For geometric, we can divide to see what was. Careful with that word, Joe. Difference is specifically subtraction, mathematically speaking. But in English, yeah, you're right. What the difference was, but I don't like that. What was multiplied, what the pattern was. I get what you mean in English, but in math, careful. So we're going to divide to figure out what was multiplied. We're going to divide to see what was multiplied. Now hold on. For arithmetic, it could go higher by adding, it could go lower or more negative by subtracting. If we're multiplying, does that mean everything's just growing all the time? How could it be shrinking and you're multiplying? Give me an example of one. Well, -5, actually, this is a weird one, Matthew. If you multiply by a -5, let's say it was 2. 2 was your first term, a sub 1. Times -5 would be -10. So it'd be like way down here on the number line, but then 5 would be positive 50. So you're actually going to do this weird, like in math we call it alternating back and forth between positives and negatives, but on both, aren't you actually going like crazy out far? So you're still expanding, just not always in the positive direction. No, I'm looking at shrinking, like getting smaller. By a fraction. Joe, I think you said 1/3? Something like that. 1/3, 3/4, 5/6, 49/50. What? That's almost 1. Yeah, but if you keep multiplying, guess what's actually going to happen to those terms? They're going to get smaller because it's less than 1. Not less than as in a negative number, which is what we were trying at first, but less than as in the magnitude is smaller than 1. Common ratio, R. Common ratio, R, like the common difference was D. And it's going to be the constant for each, I'll just say consecutive term. You guys remember recursive sequences, right? Recursive shows the pattern, has the K usually, unless they, I don't know, make it something else. Or unless we're in our calculators and we're using like U's. Can't we say then that A sub K is equal to, hold on, how do I talk about the previous term if A sub K is my current term? Good. So I can say A sub K minus 1, and since the minus, that got kind of messy, I'm going to put over here times R. Does that make sense? So in order to get any new term, you have to take the one right before it and say times R. And we saw some of these in section 9.1. We saw arithmetic ones, we saw geometric ones, and we saw neither. We saw other types. But anyway, guys, sequences and series, which one is this one if it's separated by commas? Sequence of event. First, comma, second, comma, third, comma, right? Even if you're doing proper grammar and you're writing a sentence, first, there should be a comma there, right? unless they've changed all the rules. They've changed a few of them since I was in high school. Well, and college, editing course. Well, and then we had Mr. Jones. But anyway, coming back. No, that wasn't a dig. He has a grammar book, doesn't he? I've heard stories. Finding the nth term. A copy of it? Go team. Anyway, sequence. Hey, guys, is there a formula for the nth term? Yes or no? Yes. But let's find the pattern. All right, so we'll get there. Have your highlighters ready. It's important. But what's the pattern? The first term. Second term. Joe's already looking for our common ratio. I heard him do some dividing. Do you guys hear it? Over. I heard the word over. He's dividing. But we need to get to the 10th term. Now, pause, just logic, real quick. Could we find the 6th and the 7th and the 8th and the 9th? Yeah, probably, because, guys, 3 times 1 is 6. And you could also find that by 6 over 3 is 2. And so you could be like, I think this is geometric. If I multiply 2 every time, and probably pretty quickly you're like, yeah, I think I'm right. And you are. And you are. So we could go ahead and just keep track like you saw me do a second ago with an arithmetic and say, okay, 1, 2, 3, 4, 5. Cool. 96, 6, 192, 7. It's getting messy. So what else could we do? How many jumps in between my first and fifth fingers?
4.
So there are 4 jumps of addition if it's addition, but there's also 4 jumps of multiplication if it's multiplication. Now, if I was to add, we say n minus 1 times d. Repeated multiplication is, repeated addition is multiplication. Repeated multiplication times r, times r, times r, times r. Couldn't I say r to the 4th? So if I'm doing repeated multiplication, if it's a power, can't I just say that a sub 10 is equal to the first guy times however many r's there are to the 9th power? Every jump is a times r, times r, times r, times r. Oh, that's an exponent, and it's n minus 1 jumps. So I can say the 10th term is equal to 3 times that common ratio to the 9th power. Well, you can think of it this way. Isn't 2 to the 9th the same thing as 2 cubed times 2 cubed times 2 cubed? What's 2 cubed? 8 times 8 times 8. I know that one's 64, and if I go again, well, I mean, if I'm trying to model to you that anyone can do it, couldn't you just do a quick little bloop, bloop, and then you would have a 2, and you'd carry the 3, and then you'd have 512? So 3 times 512. That wouldn't be too bad. Wouldn't that be 1536?
Yeah. Oh.
Does the formula make sense? Anytime you want the, remember, not just a sub n, but what it means, the term in the nth spot. You can start with the first spot, times your common ratio, which is your pattern, times r, whereas before it was plus something times d. But how many r's? Well, n minus 1. N minus 1. Ooh, if that's the nth term formula, what else do you guys think is coming? Nth partial sum. But before we get to the nth partial sum, let's play around just a little bit. So what are we going to play around with? Find the 12th term of the geometric sequence. Oh. Wait a minute. No, it's geometric. Shouldn't they be getting bigger? Sometimes get smaller. Just like adding could also, well, subtracting could be adding the opposite. Dividing could be multiplying by the, Isn't there a way to find the common ratio? And isn't it you take the second one over the first one, or the third one over the second one, or the, who wants to do 24 over 96? But how about 6 over 24? Can't I just say that's 1/4? What do you guys think? What's this times 4? 80, 16. 80 and 16 is 96. Oh. What's my common ratio? 1/4. What happens if you multiply a number by 1/4? Well, it ends up dividing. Dividing and dividing and dividing and dividing and smaller and smaller and smaller and smaller. So the 12th term, well, the 12th term is going to be the, follow your pattern, the first term times how many 1/4s? Let's use a calculator. I had fun with the 2's raised to the 9th, but the 4 raised to the 11th, that's going to be a little more mental math than I'm exactly willing to do. Whoa, whoa, whoa. Do you guys know how to do this in your calculator? Use your caret button, right? And you can do like the 1/4 in parentheses. You can do it as a little fraction you do. You can do it as a decimal, 0.25. Matthew's already thrown it in. What'd you get, Matthew? 2.28. Ooh. Hey, if we start getting that, which we'll only do if it's really small, what's it talking about? Or really big? And scientific notation would technically tell me that there should be 1, 2, 3, 4 different zeros, right? And then that one extra additional decimal place. Anyway, that's more than enough. Whew. Yeah, wasn't going to do that by hand. How about this one, though, where, oh, what's going on here? Do you guys see what the wording says? There is no indicated sum. Doesn't make sense, yeah. Look at the problem. What is unknown that they're asking for? Yeah, I don't know the first term, and they're asking for the first term, so what word should I take away? All right. We weren't to sum yet. Find the indicated term of the geometric sequence. Okay. My formula people, could you set up a formula with the a sub n and have a couple different ones, system of equation it and substitution? Yeah, it'd be like an exponential function. But my pattern people, haven't we been doing patterns all section? Couldn't we say the second term is 3? Don't know the 4th, but we do know the 5th. How many jumps are there between this to this? Anybody figure out what was multiplied? No. What was divided?
1/8.
Ooh. What? 3/8 times 1/8 is 3/64. Keep on going. So if we're multiplying by 1/8 every time, what would have been there before the division by 8 to get 3? You realize to go forwards, you multiply by the common ratio, and to go backwards, you divide?
3/64 is the 5th term. Oh, no.
Oh, did I put in the wrong blank?
Yeah.
Oh. Good job, my logical ones. What you did, the 1/8, was perfect for what I showed. But how many blanks did I need to leave between the 2nd and the 5th? So actually, it's even a little easier. I don't know if it's a little easier. Yeah, it's not going to be 8. It's going to be 4. Because 3/4, 3/16, 3/64. Okay. Wait. Did you guys hear it? Was it right? Is Jason right? Is it 12? Oh, Joe said it first? Divided by 4, divided by 4, divided by 4, divided by 4. No formulas necessary. Could you have done the formulas? Yeah, I suppose. Did you need to? A sub 1 equal to 12. What did we not see yet? Well, a couple things. We are going to have to keep going. Oh, look, it's an S sub n formula. But we're also going to see tomorrow what happens when the top of that S sub n has an infinity. We saw that just a little bit in section 9.1. We'll see it a bit more in section 9.3. Sometimes it's a number and sometimes it's not. But we do have a couple things to do tomorrow. But if I were you guys, I would grab a picture of this S sub n formula because you already know what it means. The nth partial sum. And I bet you could bust out at least half of homework.